Now that we have programmed the user interfaces, we're going to program the rack components. I mean all the cards that are in the rack. Here you see the in and output cards of the rack. We see a microphone card. Every RJ45 connector means one balanced mic input. So we see here 4 mic inputs A, B, C and D. But every input also has 2 GPOs and 2 GPIs. The line input RJ45s are designed to have 2 balanced inputs per connector and 2 GPIOs. The GPO is dependent upon a jumper setting on the card and can be a GPO and also a GPIO. The GPO is ground free and the GPIO is TTL in and out. The microphone's factory default is with GPIO. The GPI can be used for cuff switching and a GPO for LED indicators that have a microphone as active. We have a digital line in and an output card, and these have GPO as default. The GPO is a relay function to be used for start and stop functions of a CD player or other player. The GPO in a hybrid on monitor card can be used to indicate red light signaling. All the functions of these cards have to be programmed before we can use them. We do that on the rack configuration page we see here. In the first column we see all the slots or positions of the cards. We see here where we can activate a word clock, in this case on an external BNC connector located on the engine card. So in other words, where you see a dot mark, the word clock comes from. Here we see the various objects we have in a rack. Slot 1 is the power supply, slot 5 is a microphone card, slot 7 is a line input card, and slot 9 is a digital card, and so on. Here we can see if there's already programmed on these devices. On the power supply device nothing is configured. On the mic card there is. We're going to have a look at the mic card by clicking on Configure. We start at the top and see a number of in and outputs. The first 3 functions are not in use in this console. So we start on position 4. 1027 with GPI. We have 8 GPI inputs. They are active because I know both GPI and GPO jumpers are set to an active state. Every slot has 2 GPIs and there are 4 slots. GPI 1 is configured as cuff and communication with the engineer. To make sure this mic, actually this GPI, is always connected to this microphone, I have to select a source function first. What source? Mic 1 I have called DJ mic, so I choose DJ mic. Which function I want to activate? There's a lot to choose from. We have a lot of functions that we can activate on the module where the DJ mic is active. This module on-off function could be used. So a DJ or news reporter can switch himself on or off air. It could also be a fader that goes up or down by way of a switch. Also buses could be switched on or off. But the most often used function of a GPI is the cuff function. The moment this momentary switch is pushed, the mic signal is interrupted and the DJ can cuff. When he releases this switch, all goes back to normal. We also have a combined cuff function that is called cuff and communication technician. This means that when the cuff switch is activated, not only the audio is interrupted, but communication is established to the engineer at the same time. In this way, a DJ can communicate very easily with its engineer while on air. There are of course start and stop functions to activate or an alert function. Alert is a standard bus per source to link two functions to an up. We can also select a module function that is part of a specific module. But in that case, such a switch will always only switch, for instance, module 1 preset A/B. Mostly you do not know where a module sits or an input source will be needed. So these functions are not very popular, maybe for very specific applications. Normally we use the source function, in this case COF and communication technician. Also here we decide if this function is allowed. When in the idle, operator 1, 2, 3 and 4 mode, in this case the default should be that it's always possible. But you can imagine that for certain functions this is not a good choice when the console is in idle or unknown mode. The GPO of the mic input has 8 GPO outputs, in this case TTL. GPO 1 indicates active source DJ mic that is active. So, if a fader and a module are active on the source where DJ mic is connected to, then this LED will be activated. The result is this LED indicates mic on. It's evident that we do also choose this time a source function. A source function belongs to a source because we want to know when this mic is active. On which module this source is active is not important. The mic on LED needs to be active when this mic is on air. It doesn't matter on which module, as long as the DJ or announcer knows that a mic is on air. GPO2 we have linked to a global function, red light 1. Now we can activate a red light lamp in the studio. It doesn't matter where the source is active or what is broadcasted. But when red light 1 is active, a relay function is activated and a GPO puts out a 5 volt. GPO time. This setting indicates how long this function is active. We can choose between pulse or continuously. 0 means the GPO is switched continuously. Normally, a red light needs to be on all the time. So, all this time the GPO needs to active as well. But if we want a pulse function, sorry, this went wrong. Then it's better to put this number to 50. Now you get a pulse of 50 milliseconds. If we type 200, a pulse of 200 milliseconds will be given. However, for red light we type 0, which means continuously. GPO active state indicates the active state of a GPO. Normally 1 is active and voltage of 5 volt is present at the GPO connector. With the active state we can program in which state an action takes place. Active state 1 means that a positive signal comes out of the GPO when activated. Active state 0 means that no signal or no action is present. Many devices are different, and some need a reverse GPO signal. Some respond to a 1, 5 volt, and others to 0. Nothing. On the front side of the rack we see 2 LEDs, one orange and one green. These we can also give a dedicated function. In this case the orange LED indicates that Phantom has been activated and the green LED indicates when it is active on a module. In this case we can easily see if a mic gets its phantom power and if it's on air, so when both fader and on switch are active. We now also know that we cannot disconnect this microphone because it's on air. We can also give it another function. The easiest way is to give it a source function. In this case, because we are input 1 on the first LED, the DJ mic. But we could also indicate when it's really on air, so with program on. We could also indicate when the cuff switch is activated. In this case, there are several options you could show on these LEDs.